Assalamualaikum. So welcome to this video. So as we have seen in the previous video, that for 0 over 0 cases of limit can be divided into 3 cases. The first one will be factorization, the second one will be conjugate, and the third one will be using the squeezing theorem. So now today we are going to focus on this part only, which is the factorization part, where if you have 0 over 0 cases of the limit, and then you will have to factorize, all right, to do the factorization. All right, so let's see the first example here. Okay, so we have this what we call limit as the approaches 1 of this expression. All right, so if you try to substitute with the value 1, so you'll get 0 over 0 case. All right, if you don't believe me, try to put in your calculator, so you'll get 0 over 0 case. So what you need to do is to use the factorization. You can't leave your answer as 0 over 0, as it is not accepted as the answer. All right, so to do the factorization, so you have to factorize the upper part and also the lower parts if possible, right? So firstly, you have not substitute the limit, so you write it back. So limit as t approaching 1, because we have not substituted the value 1, right? So what we need to do is to factorize the upper part first. All right, so t squared plus 3t minus 4, you can even factorize using your calculator, so you will get t minus 1 and t plus 4. All right, so the lower part, which is the denominator, will be t minus 1, remain as t minus 1. All right, so now you can see that this term will be the same, so it can be cancelled. All right, so leaving only. All right, so still you have not substituted the limit, you have not substituted the limit as t approaching 1. You have to write it back. All right, so limit as t approaching 1 of what term left is that t plus 4 only. All right, so t plus 4. So now what you have is that limit as t approaches 1 as t plus 4. So you can substitute it with the value, so you don't have the t limit anymore, because you already substituted this t equal to 1 into this t. All right, so you will have 1 plus 4. All right, please note that we don't have the blue limit there. All right, so 1 plus 4 will be 5, meaning to say as t approaching 1, so that expression, that function will approach the value 5. Okay, so this is how you solve the question using the factorization method. All right, let's look at the second one. If you try to substitute the value x equal to 0 in the numerator and also the denominator, so you will get 0 over 0 case, so which is the case where you have to use the factorization. So for the upper part, you will be all right. So as long as you have not written you have not substituted the limit, so you have to write it back. All right, limit as approaching 1, you just copy them. All right, so you factorize the numerator, so you will have x, right, living with 2x plus 3. All right, also at the denominator you can leave as 4x. So take note that we can cancel these x here because they are the same. All right, so we'll have this. All right, so you will have to copy the limit as x approaching 0. Yes, because we have not substituted x equal to 0, so we copy them, limit as x approaching 0. All right, so we'll have 2x plus 3 over 4. Okay, so now when you can try to substitute with x with 0, so x approaching 0, so this will be substituted here, so you will have 2 multiplied by 0 plus 3 over 4. Please note that we don't have to write this limit as x approaching 0. Why? Because we have substituted 0 here. All right, so you don't have to write that limit as x approaching 0 here. All right, so now you'll have the final answer as 3 over 4. Okay, so for this type of function, you have to do factorization and get the 3 over 4 instead of 0 over 0. Please don't leave your answer as 0 over 0. It is not accepted. All right, so let's look at the number 3. All right, so look at number 3. All you need to do when you have the function, you have to substitute with the value given of the given point. So in this case, if you try to substitute with negative 2 inside there, right, let's try. So you don't have to write the limit because we already substituted it, right? So we'll have negative 2 square minus 3 over negative 2 plus 2. Alright, so what you have is actually 4 minus 3 over 0. So this is actually 1 over 0. So this is not 0 over 0 case. This is not the same as 0 over 0 case, alright? But this is 1 over 0. So anything divided with 0, later on you will learn in this topic that 1 over 0 will be approaching to infinity. So you can't say that it is actually what do we call that, 0 over 0 case here. So the final answer is actually approaching infinity, right? So this will be infinity, okay, because it is approaching that negative 2 there. So you have 0 at the denominator, so it will be infinity. The final answer is infinity. All right, so let's look at number 4 here. All right, so if you have limit as k approaching 3, all right, so the variable can be anything. It can be x, can be k, depends on this. All right, so can be x, can be k, can be y, can be t, or any variable used. All right, so in this case they use k. So what you have to do, all right, if you try to substitute with the value 3, meaning to say that 3 square minus 9, you get 9 minus 9 is 0. And at the denominator, so you'll get 3 minus 3 over 0. So this is 0 of 0 case. So what you have to do is to do factorization. So for this factorization, where if you recall your algebra, if you have a square minus b square, so this can be factorized as, alright, so 1 plus 1 minus a at front and b at the back there. So a plus b, a minus b. So same as this, if you try to substitute, if you try to factorize it, all right, so you'll have k plus 3. Okay, if you don't see that, never mind, I'll write one by one. K square minus 3 square over k minus 3. So, all right, so you'll have something like k plus 3, k minus 3 over k minus 3. But what's the problem in my working? All right, so there's something left there, meaning the one thing that I'm believing here is actually writing the limit. If we have not substituted the limit with x k equal to 3, so what you have to do is actually you will have to write it back again and again. So you'll have, all right, so limit as k approaching 3. All right, so still at the next line we have not substituted k with 3, so limit as k approaching 3. So all right, so you can cancel the same term, so k minus 3 and k minus 3. So again, have we substituted k with 3? Not yet, so you'll have to write it again and again. All right, so k plus 3. Right, so are you going to substitute it now? Yes. So when you substitute it, so you'll have k equal to 3, so you substitute here, so you'll have 3 plus 3. So your final answer is actually 6. All right, so instead of 0 over 0, so you'll have 6 as the final answer. Okay, so let's look at number 5 now. All right, so if you have this type of function, so you want to substitute with the negative 3, so of course you will get 0 over 0 case if you try to substitute. All right, if you don't believe in me, press your calculator. All right, so you'll get 0 over 0 case. So what you have to do is to do factorization, because we are now on the topic of factorization. So it's clearly you must use the factorization. So please remember that we have not substituted the value x equal to negative 3, so please write the limit as x approaching negative 3. But please, in exam you don't have to put this arrow. All right, so this arrow is just for you to be clear about that. All right, so you factorize the numerator. So in this case, if you factorize your numerator, you'll get x plus 3, x minus 10. Okay, so the numerator remains as x plus 3. All right, again, so this is the same term, so you can cancel that. All right, so now you have the next line where the limit has not been substituted yet, so please write it back, -3. All right, so you have x minus 10. All right, so now you try to substitute the value of x with -3. All right, so substitute it there, so you'll get -3 minus 10. So in this case, your final answer will be -13. All right, so as that's approaching -3, so the function will approach -13. All right, so let's move to number 6. Yeah. Okay, so number 6 is quite unique because it involves this kind of another number in front of x there, which is 2x squared. All right, so never mind, you have to know how to factorize, because factorization you should be learning this since form 3 if I'm not mistaken. All right, so firstly, what you have to do is always copy the word limit as approaching 2 in this case. All right, so now you have to factorize the numerator. You can even use your calculator actually. All right, so if you use your calculator, so you'll x minus 2, 2x plus 3. All right, so you'll have these what do you call these terms? All right, so 2 minus x. All right, so now this is quite interesting, since you cannot factorize, you cannot simply cancel this, because they are not the same. X minus 2 and 2 minus x is not the same. So what you have to do is to do some kind of factorization of the negative symbol. So how to do that? So you'll have, okay, let's say I want to factorize the denominator. All right, so 2x plus 3. So how do you factorize a negative there? So you'll get negative. All right, so -2 plus x, something like this. All right, so this shouldn't be weird to you. This should be normal, all right, you should know this. All right, it's approaching 2. All right, so for the next line, you have not cancelled that, so you copy x approaching 2 then. All right, so what you can do is actually you can rearrange the variable, the unknown, all right, at the denominator. So you'll have something like negative there. All right, so you can rewrite it as x minus 2. All right, so you can cancel x minus 2, x minus 2, it's because it's now the same. All right, so please take note the difference here. You are not allowed to cancel until you can reach to this part. Okay, so you can cancel now. You will have, all right, so let's say all right, so you have not substituted the limit, so you have to write it back. All right, so you'll have something like 2x plus 3 over, all right, you have negative, means -1. Okay, so now you can try to substitute with the value of x, which is 2. So you substitute it there, so you'll get, all right, so something like 2 multiplied by 2 plus 3 over -1. So 7 over -1. So the final answer will be -7. Okay, so this is quite unique here because you have to do some kind of factorization of the negative symbol. So please don't be don't be quite weird about this function. Okay, so let's move to number 7. All right, if you have 1 plus t squared minus 1, if you substitute with the value of t with -1, so of course you will get 0 over 0 case here. All right, 0 over 0. So what you have to do is to do the factorization. All right, so always don't forget this limit as t approaching -1, because we have not substituted the value of t with -1 yet. So now we have, okay, let's say the numerator, we are not doing anything there, so just copy. But the numerator, all right, so please take note that t squared minus 1, all right, if you can't remember, so you have to write it back. You recall that t squared minus 1 means that it is actually t squared minus 1 square, because 1 is actually 1 square. So if you have 2 squared minus 1 squares, you will get t plus 1, t minus 1. All right, so this is the term that we want. So you have to substitute here as t plus 1, t minus 1. All right, so is there anything which is similar? So you have 1 plus t, t plus 1. It's actually the same. You can rewrite that. All right, so you'll have, all right, so you have not substituted the value of t with -1, so please write this limit as t approaching -1. So what you have to do, okay, the common mistake that students make when they cancel that, they simply write t minus 1. This is not the same as 1 over t minus 1. This is wrong, all right? So what you have to do is actually, you'll have to write, okay, so this is at the, all right, please take note that this is at the denominator, but this is at numerator. You have the term, when you cancel, you simply cancel 1 actually. You're living with 1. So you have 1 at the numerator, and at the denominator, you still have this t minus 1. Please take note that you don't leave this 1 there, all right? So now, you can try to substitute with the value of t with -1. So substitute here. So what you have is actually 1 over t will become -1, -1 minus 1. So this will be 1 over -2. So you can simply write -1 over 2, -half. Okay, so this is also quite interesting here, but please take note about this thing, that this is actually 1 over t minus 1, not t minus 1 itself. All right, so let's move to number 8 here, where you have a limit as approaching square root 2 or third 2, all right, of this term. All right, so if you try to substitute, sorry, you have square there, all right. If you have that, you know, if you substitute with square root 2 at x, sorry, I'm doing mistake here. This is x, right? Okay, this is the correct one. If you substitute with square root 2, then you will get 0 over 0 case, right? Because you have square root 2 square minus 2 over square root 2 minus square root 2. So this will be square root 2 square will be 2 minus 2 over square root 2 minus square root 2. So this will be simply 0 over 0 case. So you can't do this. You have to factorize, right? So one way of factorization is actually, okay, so please take note that, okay, we are not substituting the limit yet, so write it back, limit as approaching square root 2. All right, so this is actually x square minus square root 2 square, all right? So please take note that 2 is actually square root 2 square. Okay, so what you have in the, what do we call, in the numerator, denominator is x minus square root 2, right? So now, please take note that if you have like a square minus b square, so this will be a plus b, a minus b. So in this case, this will be written as, right? So x plus square root 2, x minus square root 2. All right, so now you still have this limit, right? So you have the limit as x approaching square root 2, and the, what do we call, the denominator still have x minus square root 2. So you can cancel the same term here, all right? So this and this, so you are living with this, all right, so you have this limit as x approaching square root 2, and then you still have this x plus square root 2. So now you want to substitute with the value of x with square root 2, all right? So you will have square root 2 plus square root 2. All right, so this is the most, you know, most students will stuck here. So this is actually 2 square root 2. How do I get that? All right, so it's something like d plus d, you'll get 2d. Donut, okay, donut plus donut, you'll get 2 donut. So if you have square root 2 plus square root 2, of course you get 2 square root 2. All right, so that's your final answer. Okay, so let's move to number 9. Alright, so you have limit as t approaching 0 of this term. Alright, so if you try to substitute with t with 0, so you'll get 0 over 0 case. Right, so this is clearly 0 over 0 case because each term contains t. So what you have to do is to factorize. Alright, so since you have not substituted the value of t with 0, so write it back, limit as t approaching 0. So you will have, alright, so you factorize t, right? So you'll have t to the power of 3 plus t to the 2t minus 1 because you factorize t then. All right, so you have, all right, it's changing color. All right, so t, all right, so you'll have 3t minus 4. All right, so look at t here, they are the same, so you can cancel them. All right, so this is left with, all right, so please write it back, limit as t approaching 0. So you will have t to the power of 3 plus 2t minus 1 over 3t minus 4. So substitute the value of t with 0. All right, so we are going to substitute each t with 0. So this t will be 0. So 0 here, and also 0 here. All right, so what you have in the final answer will be 0 to the power of 3 plus 2 multiplied by 0. Please show in your working. All right, so 3 multiplied by 0 minus 4. So your final answer will be negative 1 over negative 4. So this can be simplified as 1 over 4. If you don't know this, that will be very, very bad. All right, so number 10. All right, if you limit as approaching negative 5 here, so you have x cube. All right, so something like this. All right, so because each term contains x, you can try to factorize x first. Right, so you'll have, all right, so please write the limit first. Limit as x approaching negative 5. So you have x, all right, x squared plus 7x plus 10 over x plus 5. So please cancel this x first. All right, so you still left with this. If you try to substitute with the value of x with negative 5, still you have 0 over 0. So what you have to do is that you still have to factorize the numerator. So you will have something like, all right, so firstly we have to write this limit as x approaching negative 5 because we have not substituted x with negative 5. So we have to factorize the numerator. So we'll get something like x plus 5 x plus 2. At the numerator you have x plus 5. Right, so please take note that they are the same here, so you can cancel them. All right, so in the next line you have not substituted the value of x with negative 5, so you have to write limit as x approaching negative 5 and living with the only term which is x plus 2. So now you want to substitute the value of x with negative 5. All right, so you will have this as a negative 5 plus 2. So negative 5 plus 2 will be negative 3. Okay, all right, so next look at number 11. Okay, if you have this type of limit, all right, if you try to substitute the value of s with 3, so you'll get 0 over 0. Okay, so of course you have to do some kind of factorization. So firstly, write the value of limit as s approaching 3. Right, so try to factorize the upper part first. All right, so it will be quite difficult if you try to factorize directly because it has negative term there. So what I want to do is that I want to factorize the negative first. So I'll put out this negative. All right, so leaving only with s squared minus s minus 6. All right, so this is what I am doing, where I factorize that negative first, and then only I factorize the s squared minus 6 s squared minus s minus 6. Right, so you can even use your calculator. All right, s approaching 3. All right, I have negative there. All right, so I want to factorize the one in the bracket there, so I will get something like s minus 3 s plus 2, and at the denominator you will have s minus 3. Right, s minus 3. So you can cancel now that s minus 2 s minus 3. So you will have something like, right, we are not substituting the s equal to 3 yet. All right, so we'll have something like negative s plus 2. So now we want to substitute the value of s with 3. So we have this s with 3, so we want to substitute here. So we will have something like negative, all right, 3 plus 2, so which is negative 5. Your final answer will be negative 5. All right, so I guess this is the last question we're going to solve in this video, so please focus. Alright, so we have this v approaching negative 7. If you try to substitute v negative 7, we'll get 0 over 0 case. So this is still 0 over 0 case. So you have to reuse the factorization. as what we have seen in the previous example. So we have to use the formula a square minus b square equal to a plus b a minus b. So you will have something like v square. 49 is actually 7 square. All right, so we have v plus 7. All right, now we want to factorize that v square minus 7 square. So we'll have something like, okay, limit as v approaching negative 7. Why we have to write this? Because we have not substituted the value of v with negative 7. All right, so we'll have something like v plus 7 v minus 7 over v plus 7. So now you can see something similar there, which is v plus 7 and v plus 7 can be cancelled because each term are the same at the numerator and also denominator. So leaving only with this one, you have not substituted the value of v with negative 7. Please write it back, v approaching negative 7 of this term, which is left with a v minus 7. Right, so now what you're gonna do is that you have to substitute the value of negative 7 into v. So you will have something like negative 7 minus 7, so you will get negative 14. So that's your final answer. But please be careful. Okay, I want to remind all students, right? So let's say we have this kind of let's say limit as t approaching 2, let's say t approaching 2, where we have t minus 2. all right, so t squared plus 5t plus 6, let's say like this. All right, if you substitute the value of, sorry, this is not 0 over 0 case, so this is, let's say I will have like t minus 2 and t plus 1. all right, so let's say we have t squared minus t minus 2. all right, so if you substitute the value of t with 2, so you'll get 0 over 0 case. So you have to factorize the what do we call that, numerator. But when you press your calculator, the calculator will give in terms of x. So the most common mistake that students make is that they write the limit as t approaching 2, but here they write as x minus 2 x plus 1, and suddenly the numerator also becomes x minus 2. I don't know where this x comes from, but please, when your calculator shows this x equal to negative x equal to 2, x equal to negative 1, all right, so please convert it according to the question. If the question gives you the variable t, so please use t here, right? So use t here. That is the common mistake that students make, all right? Because if you have t approaching 2, but if it is x there, how are you going to substitute the value of t with 2 at the value of x? This is possible. This is what I mean, right? If you cancel x minus 2, so you'll have limit as t approaching 2, so you have x plus 1. Then students stuck here. Why? Because this is t, this is x. They cannot substitute the value of x with t, which is 2, right? So check out my next video for the 0 over 0 case. all right, for 0 over 0 case using the conjugate. all right, so using the conjugate, so we'll see this in the next video. Thank you for watching.